Okay, let's look at an example where we have two features. So we have y equals w0 plus and then w1x1 plus w2x2. And I've drawn here a cost function in function of the weights. And we get typically a sort of 3D shape like this. Yeah? When x1, x2 is 0, that means that your cost function equals to w0. So w0 is the height of the 0 till the end of this cone. I printed out a cost function here in function of the parameters. And basically in gradient descent, you'll start in a point and you converge to the minimum. Yeah? So what we're going to do now is we're going to look at this picture from the upside. So we're going to project this picture to the W1, W2 plane. And when we project, we get contours. Here we go, something like this. Yeah. And this we call the contour plot. Contour plot. Yeah, and such a line gives a constant cost. Constant cost. Yeah. So each of these circles represents a situation where the cost is constant. Now, how we gonna draw the gradient? Well, first of all, you can imagine that, by going to that minimum, the gradient must point inwards because we need to end here and we start here. So the gradient is gonna point inwards. The second thing is that we know from derivatives that the gradient is tangent to the contour lines. Yeah. And the third thing is that the gradient will go into steepest descent. Why steepest descent? Well, it's quite easy to intuitively grasp that. So when you're here and you want to go to the next line, you can do this, yeah, or you can do this, or you can do this, Well, we see here that this is not steepest descent, this is not steepest descent, this is steepest descent, and this is exactly your gradient because it's then perpendicular to the contour line. Okay? So this is important to understand. Here we have a convex function. This function is convex. So we have only one minimum, and the minimum is a global minimum. But as we have seen, functions are not always convex. So in this case, let me just quickly, draw a gradient here, perpendicular, and then you move like this to the minimum. Okay? So when a function is non-convex, we can have several local minima. Yeah? So here in this picture you see when I start on the left I end up in this minimum. When I start a little bit further I end up in this minimum. So the non-convexity is something we will need to deal with when we're using gradient descent.